Right, so this is the 2015 paper here. Question 7. A sequence of figures is made up of regular pentagons using sticks of unit length. The first three figures in the sequence are shown below. So we have figure 1, figure 2, figure 3. The vertices in each figure are marked with dots. So figure 1 has 1, 2, 3, 4, 5 dots. Right? So figure 1 has one pentagon. So I'll put in one here. Figure 2 has two pentagons. Figure 3 has three pentagons. Figure 4 should have four pentagons. An incomplete diagram for figure 4 of the sequence is shown below. Complete figure 4 by adding more sticks and dots. So from figure 1 to figure 2, you draw a pentagon that is kind of down, and then you another pentagon for figure 3 kind of rise up. So the fourth pentagon here should kind of rise down. In other words, so it should look something like, put a dot here, put a dot probably like here, put one here, one like there. Let's see if that forms the pentagon. Um, like there, um, like that. Right? So it's not perfect, but I mean this is it here, right? So this is figure 4 for 2 marks. So you just add on a pentagon, looking like a drop. Now part B, this says study the pattern of numbers in each row of the table below. Each row relates to one of the figures in the sequence of figures shown on page 22. Some rows have been included in the table below. Yeah, figure 1 has 5 sticks and 5 dots. Figure 2 has 9 sticks and 8 dots. Figure 3 has 13 sticks and 11 dots. So looking at the pattern coming down for the column there. So for the number of sticks from figure 1 to figure 2, you increase by 4. From figure 2 to figure 3, you increase by 4 as well, because 9 plus 4 is 13. Because I am increasing by 4, I put the 4 there and I multiply by the figure number, which is n. And I tried for figure 1. So it will be 4 by 1, which is 4, but I have a 5 there. So I know if I have 4 and I add 1, I'll get the 5. Right? And then I tried for figure 2. So I will get 4 by 2, which is 8, plus the 1 that I have on top will give me 9. And I have a 9 there. Tried for the third figure. So it will be 4 by 3 plus 1, which will give me 4 by 3 is 12 plus 1 is 13. And I have 13 for the number of sticks. Therefore, I need to just add a 1 here to the 4n, and that is my formula for the number of sticks for figure n. Then I look at my general trend for the number of dots. From 5 to 8, that is an increase of 3. Right? Right? So continuing there. So finding the formula for the number of dots, we look for when we're going from figure 1 to figure 2, there's an increase of 3, and then from figure 2 to figure 3, you have another increase of 3. So since you're increasing by 3, you multiply n by 3, so you're going to get 3n. Try it for figure 1, you'll get 3 by 1, which is 3, but you have 5 there, so if I add 2, and I try it back for figure 1, I'll get, when n is 1, I'll get 3 by 1, which is 3, plus 2, which is 5, correct? Then when figure 2, I have n is 2, so it will be 3 by 2, which is 6, plus 2, which is 8, and 3 by 3, which is 9, plus 2, which is 11, so it works out there. Alright, so let me just clean up this a little bit. Right. So now I'm going to use these formulas to fill out the missing spaces. So I have 4 by 20, because now n is 20, plus 1 would be 81, because 4 by 20 is 80 and 80 plus 1 is 81. Then this one will be 3 by 20 plus 2. 3 by 20 is 60 and 60 plus 2 is 62. Now I have, for the number of 6, I have 169. So I can simply say the formula, which would have been 4n plus 1, would be equal to the 169. Here across the 1, I'm going to get 4n is equal to 169 minus 1. So 4n is equal to 168. So n will be equal to 168 divided by 4. So n will be equal to 42. So n is 140. Well, n is 42, so I'll put the 42 there. Now I have to find the number of dots for the 42 for the second figure. So it will be 3 by 42 plus 2. And this given me 128. And that is my answer, therefore 2 for 6 marks. Right? So going on to the last part here now. They say write an equation in S, D, and N to show the relationship between the number of sticks S and the number of dots D for the figure N. So I'm going to write the number of dots, which is 3n plus 2. I'm going to leave a little space there and I'm going to put equal to 4n plus 1, which is the formula for the number of sticks. So I have to write an equation relating the number of dots to the number of sticks. So I have 3n here, but I have 4n here. How do I go from 3n to 4n? I simply add n. I have positive 2 here and I have positive 1 here. How do I go from positive 2 to negative to positive 1? I simply minus 1. So I am adding n minus 1 to the 3n plus 2 to get the 4n plus 1. So now I'm going to replace the 3n plus 2 with the letter for the number of dots, which is D. Put back my plus sign. Going to put the n minus 1, and that is equal to 4n plus 1, which is the number of sticks, which was S. And that is my equation relating D, N, and S. You all understand the solution here for this question? So the 2024 paper here now, question 7. The city diagram below shows the first 4 diagrams in a sequence of regular hexagons. Each regular hexagon is made using sticks of unit length. So you have diagram 1, diagram 2, diagram 3, diagram 4. Diagram 1 has 1, 2, 3 hexagons. Diagram 2 has 1, 2, 3, 4, 5 hexagons. Diagram 3 has 1, 2, 3, 4, 5, 6, 7 hexagons. Diagram 4 has 1, 2, 3, 4, 5, 6, 7, 8, 9 hexagons. So diagram 5 should have 11 hexagons. How did I get 11? From 3 to 5, you add 2. From 5 to 7, you add 2. From 7 to 9, you add 2 as well. So complete the diagram below to represent diagram 5 in the sequence of regular hexagons. So how much we have here so far? We have 1, 2, 3, 4, 5, 6, 7. We have 7, but we need to get 11. So how much do we need to add there now? We need to add 4, because 7 plus 4 is 11. So if you notice, the bottom of the shape, the bottom hexagons, is usually one more than the top. Right? For figure 1, you have 1 on top and 2 at the bottom. For figure 2, you have 2 at the top, 3 at the bottom. Diagram 4, you have 3 on top but 4 at the bottom. Right? So we need to have one more at the bottom. So I can input 1 here. How am I putting that there now? I could put 1 here. that is 1. I can put another 1 here. Right? I could input 1 at the bottom here. Right? Although it's not looking like a hexagon, it is. Let me see if I can input 1 more here at the bottom here. Right, so we have 1, 2, 3, 4, 5 on top. We have 1, 2, 3, 4, 5, 6 at the bottom. So 5 plus 6 is 11. So we have the correct amount there. Right? Remember, on top should have 1 less than the bottom, or the bottom should have 1 more than the top. Right? Now, let's say the number of regular hexagons and the number of sticks that making up the hexagons and the perimeter of each figure P follow a pattern. The values of H, S, and P for the first 4 diagrams are shown in the table below. Study the pattern of numbers in each row of the table and answer the questions that follow. Complete the rows marked 1, 2, and 3 in the table. So what we have here now is diagram number 1 to 5, and then we have n. We have the number of hexagons for the diagram 1 to 4, as well as the number of sticks and perimeter for 1 to 4. You have to fill in 5. So first of all, I like to fill in the formula, which is part 3 here, and then I can work my way up. So for the number of hexagons, this column coming down from 3 to 5, that is an increase of 2. From um, um, all right, so yeah, from 5 to 7, that is an increase of 2, and 7 to 9, that is an increase of 2 as well. So I keep increasing my 2 come down, so I could say that is consistent. So I put 2 there and I'm multiplying it by n. Try it for diagram 1. 2 by 1 is 2, but I have 3 there. So if I add 1 to this, I get 2 by 1, which is 2, plus 1, which is 3. Then 2 by 2, which is 4, plus 1, which is 5. And 2 by 3, which is 6, plus 1 is 7. Then 2 by 4, which is 8, plus 1, which is 9. So therefore it works for the first 4 diagrams. So it will work for the 5th diagram as well. So I said 2 by 5 plus 1 is 10 plus 1, which is 11. I fill in out the other column as well for the number of sticks. So 5 to 23 is an increase of 8, as well as 23 to 31 is an increase of 8, and 31 to 39 is an increase of 8. You're adding 8 now, coming down. So you say this is going to be 8n. So you're going to be 8 by 1, which is 8, and then 15 minus 8 is 7, so you're going to be 8n plus 7. 2 by 8 is 16, plus 7 is 23. 8 by 3 is 24, plus 7 is 31, and 8 by 4 is 32, plus 7 is 39. So it works for the first 4 figures, so it can work for figure 5 as well, for diagram 5. So it going to be 8 times 5 plus 7, which is 47. I'll put 47 there. Right? Then the parameter, so you're increasing by 4 from 12 to 16, that is a 4. 16 to 20, that is an increase of 4. 20 to 24 is an increase of 4. 24 to 28 is an increase of 4. So I put in number 4 there and I'm multiplying by n for diagram 1. Sometimes I don't call diagram figure, but diagram 1 is 4 by 1, which is 4, but I have 12 there. So 12 minus 4 is 8. So if I put plus 8 there and try it for the other figures. Figure 1 it could be 4 by 1, which is 4, plus 8, which is 12. It will work out there. Then 4 by 2, which is 8. and 8 plus 8 is 16, works out. 4 by 3, which is 12, and 12 plus 8 is 20. 4 by 4 is 16, 16 plus 8 is 24. 4 by 5 is 20, plus 8 is 20, so it works out there. Now we need to find n when the number of hexagon is 47. So I'll simply let the formula be equal, formula is n plus 1, let that be equal to 47. So 2n would be equal to 47 minus 1. So 2n would be equal to 48. Therefore, n will be equal to 48 divided by 2. Therefore, n will be equal to 24. So, no, wait a minute. That is 46. I make an error there. So it'll be 47 minus 1, which is 46. So it's 46 divided by 2, which is 23. And so you see, it was important to double check. Now that n is 23, we need to find the perimeter. So it can be 4 by 23 plus 8. 4 by 23 plus 8 is 100. So my answer is 100 there. Alright, now part C, this is Skylar says that she can make one of these figures with a perimeter of exactly 1005. Explain why she is incorrect. So notice that the perimeter is 1005. So we let the perimeter be equal to 1005. But what is the formula for the perimeter? The formula for the perimeter that we got was 4n plus 8. So we let this be equal to 1005. And we solve for n now. Carry across the 8. You're going to get 4n is equal to 1005 minus 8. So 4n will be equal to 997. So n will be equal to 997 divided by 4. So n will therefore be equal to 249.25. But this is not a whole number. This is not an integer. Since it is not an integer, this is incorrect because you need a whole number, or you need a whole integer, or you need an integer, right? So n is not an integer or a whole number. It's not an integer value. So it is not possible. It is not a possible figure. It is not a possible figure. Because the answer in terms of decimals there for n, right? And that's basically the solution for this question. And let me know if you have any questions. So the 2023 paper, let's say a sequence of designs is made using black disk and white disk. The first three designs in the sequence are shown below. So you have design 1, design 2, design 3, and design 4. In the space provided on the grid above, draw design 4. So notice something, you have 3 black dots at the base for design 1. Then design 2, you have 4 black dots at the bottom. Then design 3, you have 4 black. You have what? 1, 2, 3, 4, 5 black dots at the bottom. So design 4, you have 6 black dots at the bottom. So 1, 2, 3, 4, 5, 6. Design 1 have 2 black dots going up. Design 2 have 3 black dots going up. Design 3 has 4 black dots going up. So design 4 should have 5 black dots going up. So you already have one there. So 2, 3, 4, 5. Everything else should be white disk. So you have one white disk above, and then you leave this row blank, and then you fill in everything else. right? Based on the pattern there. Fill it in like this. And that is basically the design for there, right? So they say part B, the number of disk, which is the number of white disk, which is W, and the number of black disks, which is capital B, and the total number of disks from each design follow a pattern. So this is the total. The values for W, B, and T for the first three designs are shown in the table below. Study the pattern in the number table. Study patterns of numbers in the table. Design number. Design number 1, 2, 3. Skip the 9. Skip the N. Right, and then we have a little pattern here. So based on this pattern here, I'm gonna write the formula for N. So for the number of white disks, you have this number is the same as the design number, the first number in the bracket. So open my bracket. Since that first number in the bracket is the same as the design number, then it should be representing the design number, which is N. Multiply the second number in the bracket also represent the design number, because look at the first one is 1, the second one is 2, the third one is 3. So the design number for this row part 3 here is N. So this will be N times N. Plus this is same thing, the design number. So it's 1, 2, 3 coming down. So this will be after. So I have to add the design number, which in this case would be N. And then you're adding 1 consistently come down, so you can just add 1 here. So that is how I get the formula for the number of white disks for the N design, the nth design. So for design 9, it will be, N is now 9, so I replace the N with 9 from the formula. It will be 9 by 9 plus 9 plus 1. 9 by 9 is 81. 81 plus 9 is 90, and 90 plus 1 is 91. So this is 91. Right? The number of black disks, you're increasing by 2 as they coming down here. So you're adding 2 coming down. So since 2 is consistent, you put 2 times N. And you try it for the first figure. But 2 by 1 is 2, but you have a 4 there. So you know if you add 2 there, you'll get 2 by 1, which is 2, plus 2, which is 4. Then 2 by 2, which is 4. Plus 2 is 6, we get a. And 2 by 3, which is 6, plus 2, which is 8, we get a. Right? Then you the total number of disks is basically the number of white disks plus the number of black disks. So it's 3 plus 4, which is 7. 7 plus 6, which is 13. 13 plus 8, which is 21. So what we're going to get here now is N by N, which is N squared, plus N plus 1. And you have to add this to the 2N plus 2. So, I mean, you only have one N squared term there, so you put back the N squared term there. But just say N plus 2N is now 3N. And 1 plus 2 is 3. So plus 3. And that is the formula there. So we follow the formula part. Now it's to follow the blanks. Right? So this is now, this blank here for part 1. It will be 2 by 9 because N is 9 plus 2. 2 by 9 is 18 and 18 plus 2 is 20. Part 2, obviously we're seeing that N is 20 here because it's N by N, which is 20 by 20, so N gotta be 20. The number of black disk will be 2 times 20 plus 2, which is 40 plus 2, which is 42. To get the total number of disks, you add the 421 plus the 42, and you should get 463. And that is basically how you fill out this table for 7 marks. Right? It says Stephen has 28 black disks and 154 white disks, and wants to make design 12. Explain why it is not possible for him to make design 12. Well, we use the formulas for the number of black discs and the number of white discs and see if he has enough of each disc. Right, so starting off with the so this is the number of disc. Starting off with the black. The formula is 2n plus 2. But what is the value for n? Since it's design 12, n will be equal to 12. So it will be 2 times 12 plus 2. 2 by 12 is 24, and 24 plus 2 is 26. So it's 26 black disc. Design 12 requires, and how many does he have? He has 28. So you have 2 more than what is required, so that is safe. You have enough black disc, right? Now let's check the white one. So the white disc. The formula for that would have been n squared plus n plus 1. So now you're replacing n with 12, so you're going to get 12 squared plus 12 plus 1. When you work out this, you're going to get 157 white disc. Right? But he only have 154, so he does not have enough white disc. So that is why this diagram is not possible for him to make. Right? So since Stephen does not have enough white disc, he is unable to make design 12. Right? And that is basically it. I mean, this is a lot of working for 1 mark, but it is what it is. Right? So that is 2023. Now we're going on to the 2022 one. Right. So number 7, at an entertainment hall, the well, at the entertainment hall, tables and chairs can be arranged in 2 different ways, as shown in the diagram below. You have arrangement L, arrangement M. Draw the diagram for 4 tables using arrangement L. Now this is 1 rectangle, this is 2 rectangles, this is 1, 2, this is 3 rectangles, this is, so 4 tables. I mean, a rectangle is a table, right? So for 4 tables, you're going to have to draw 4 rectangles. I'm going to try my best to draw it neatly. That is 1. Right, second one. That is the third one. And that is the fourth one. So now we have to draw, so that's the 4 tables. Now we have to draw the chairs. These are the chairs around the tables. We're looking at arrangement L for now. We're not really concerned with arrangement M. So we have 1, 2. I don't think I'm going to shade them. It's taking up too much of time. Another one, another 2 here. Another one there. Another one here. So there are 2 tables, 2 chairs above each table, and there are 2 chairs at the bottom of each table as well, based on the pattern. These little boxes are representing the chairs. You have 3 chairs to the left and to the right of the ends of the table. So I have to draw 3 here. So 1, 2, 3. 1, 2, 3. So that should be your diagram here, right? You probably shade it as well. Right. You just want to shade it just like how you have it in the diagram there. Since I started, I might as well complete it. Right, so something like that, right? So going on to the next part now. So let's say in part B, the number of chairs C that can be placed around a given number of tables, capital T, for either arrangement L or M forms a pattern. The values for C for the first 3 diagrams for both arrangements are shown in the table below. Study the pattern of numbers in each row of the table. So you have complete the rows numbered 1, 2, and 3. So you have table 1 to 4. Well, actually, they give you table 1 to 3. The number of chairs for arrangement L and the number of chairs for arrangement M. Right? So when you have one table, arrangement L has 10 chairs. You have one table, arrangement M has 10 chairs as well. You have 2 tables, arrangement L has 14 chairs and arrangement M has 16 chairs. You have 3 tables, arrangement L has 18 chairs and arrangement M has 22 chairs. So we look at the pattern coming down. You increase by 4, you increase by 4. So you're adding 4. So I'm going to write this as 4n. But try it for the first table. It will be 4 by 1, which is 4, but I have 10 there. So if I add a 6 here, I will get the 10 when n is 1. Try it for when n is 2, I subs to get 14. So 2 by 4 is 8, and 8 plus 6 is 14. I have that. When n is 3, I'll get 4 by 2, which is 12, and 12 plus 6 is 18. So I'm getting that. So the number of chairs, let me fill out the formula first. From 10 to 16, and then 16 to 22, you're increasing by 6. So I say 6 by n. When n is 1, I'll get 6 by 1, which is 6, but I have 10 there. So if I add a 4 there, I'll get the 10. And then 6 by 2 is 12, plus 4, 16, and 6 by 3 is 18, and 18 plus 4 is 22. So these formulas will work, right? So I tried for the fourth table. So I'll get 4 times 4 plus 6. 4 by 4 is 16, and 16 plus 6 is 22. This one will be 6 by 4 plus 4, which will give me 28, because 6 by 4 is 24 and plus 4 is 28. Part 3, well, I have the number of arrangements. Well, I have the number of chairs for arrangement M is 130, and I had the formula for that is 6n plus 4. So that should be equal to 130. So 6n will therefore be 130 minus 4. So 6n will therefore be equal to 126. N will therefore be equal to 126 divided by 6. N will therefore be equal to 21. So I'm replacing here with 21. That is the number of tables. So you have 21 tables there. Now, the number of chairs for arrangement L when you have 21 tables will be 4 by 21 plus 6, which is basically 90. That is my answer there. Now part C, they say Leon needs to arrange the tables or arrange tables to seat 70 people for a birthday party. So you have T is equal to 70. In other words, N is equal to 70. Because N represents the number of tables. Right? Oh no, my bad, to seat 70 people, my bad. That is, he don't need 70 tables. If he needs to seat 70 people, then the number of chairs should be 70. So you should have 70 chairs. Right? Which of the arrangements LOM will allow him to rent the least number of tables? Now remember, the number of tables was n. So you let each of the formula, the 4n plus 6 and the 6n plus 4, be equal to 70, since those formulas were for the number of chains in the arrangement L and M. You let the 4n plus 6 be 70 and the 6n plus 4 be 70, and you solve for n in both cases. And the one with the smaller value will be the one with the least number of tables. So I'm going to say using L arrangements, we're going to have 4n plus 6 is equal to 70. So 4n will be equal to 70 subtract 6. So 4n will be equal to 64. So n will be equal to 64 divided by 4. N will be equal to 16. And this will be tables. So it's 16 tables. Now using M arrangements, we have 6n plus 4 is equal to 70. So 6n will be equal to 70 subtract 4. So 6n will be equal to 66. Then n will be equal to 66 divided by 6. N will therefore be equal to 11. So arrangement M gives the least number of tables. Which arrangement LOM will allow him to run the least number of tables? It will be arrangement M. So arrangement M will allow him to rent the least number of tables. Right? That is the answer for that there. So the last one we're going on to now is the 2021. Alright, so I'm going to correct this one now. So they say the first three figures in a sequence of shapes formed by connecting lines of unit length are shown below. So you have figure 1, figure 2, figure 3, figure 4. So figure 1 has like, this is one square, figure 2 has two squares. I'll call them houses. So this has one house, figure 1, figure 2 has two houses, figure 3 has three houses, figure 4 should have four houses. Right? I'm gonna put one here. So this is 1. This is the second one. Third one. Fourth one. right? They say the number of lines in each shape and parameter of the shape follow a pattern. Study the pattern of numbers in each row of the table below and answer the questions that follow. So I have to complete table 1, complete table below showing the number of lines and the parameter of each figure. So the number of lines, you look at the general pattern coming from figure 1 to figure 2 and then to figure 3. So you're increasing by 4. Well, you're increasing like, no, 5. 5, my bad. You're increasing by 5. Because 11 minus 6 is 5. And 16 minus 11 is 5. So since you increase my 5 coming down, you put the 5 there, multiply by n. You say 5 by 1 is 5, but you have 6 there, so add 1 will give you 6. And then try for figure 2, 5 by 2 is 10, plus 1 is 11, and then for figure 3, 5 by 3 is 15, plus 1 is 16, so it works. Then for the parameter, you're coming down, see if it's increasing by a fixed amount, which is basically 3, correct? So you put 3n now. Try for figure 1. Be 3 by 1, which is 3, but you have 5 there, so you add 2. Try it for figure 2, it could be 3 by 2, which is 6, plus 2, which is 8. For figure 3, 3 by 3 is 9, and 9 plus 2, which is 11. So it works out. Right? So we have 3 and plus 2. So now we use these formulas to fill out the rest. So this will be 5 by 5 plus 1. 5 by 5 is 25 plus 1, which is 26. Then this is 3 by 5 plus 2, which is 15, plus 2, which is 17. Then to get the figure number, you already know that the number of lines is 66. So you're going to let the formula for the number of lines of L, which is 5n plus 1, be equal to the 66. So you're going to get 5n to be equal to 66 minus 1. So 5n is equal to 65. So n will be equal to 65 divided by 5. So n will be equal to 30. So you're going to put 13 there. Then you're going to say this is 3 by 13 plus 2, which is basically 41. 41 is my answer. Right? And then the last part here now, they say write the simplified expression in terms of n for the difference between the number of lines and the parameter of any figure. So we basically find the difference between the formulas. So that will be d. D is the difference. That is equal to the number lines, which would have given you the larger value. So that's why I say in this minus the parameter, because the parameter would have yielded the smaller value. So it can be 5n plus 1 subtract 3n plus 2. So right, and mark the d for the difference. 5n minus 3n is 2n, and 1 minus 2 is negative 1. So this is the formula here for the difference between the number of lines and the parameter for any figure. Alright, so that is the solution there. Do you have any questions for this topic? Are you guys good with this topic covered today?